This is lesson 6.5, solving exponential equations. You should be on page 326 of your book. In this lesson, you will learn how to solve exponential equations that have the same base, how to solve exponential equations with unlike bases, and then how to solve exponential equations by graphing with your calculator. So let's talk about how we solve exponential equations with the same base. Now, I guess before we even get to that, we need to figure out what is an exponential equation. What does that mean? It means that we have equations that have variable expressions as exponents. Okay? So you might be like, well, boy, that doesn't really make anything clear. So what does that mean when we have equations in which variable expressions occur as exponents? Well, here would be an example of that. You can see we have an equation, but our variables are in the exponents. That's maybe another way to think about that. It's an equation that has variables in the exponents. That's an exponential equation. Okay? So we're going to learn how to solve those types of equations when we have the same base first. Now, in order to do that, we have to know this, that two powers with the same positive base, b, where b is not equal to 1, are equal if and only if their exponents are equal. So that sounds, again, kind of confusing. This is a fancy way of saying if you have something like 2 to the third power equals 2 to the x plus 1 power. Now, I want you to notice, do you notice how we have the same base? We have a base of 2. Let me underline that. We have a base of 2 for each. If we have the same base, the powers must be equal. That means 3 must equal x plus 1. So now I could solve that. If 3 equals x plus 1, that means x must equal 2. So my power here, so 2 to the 2 plus 1 power, 2 to the third power would equal 2 to the third power. X must be 2. So that's what this property is saying. If we have the same base and we have an equal statement, our exponents have to be equal. Now I can use that to solve equations with the same base. Like, let's look at these examples. In the first example here, 3 to the x plus 1 power equals 3 to the fifth power. Now do you notice how we have the same base, 3? Well, since the bases are the same, the x plus 1 power has to equal the fifth power. Well, then that's easy to solve. You can see what they're doing here. They're just going to take away 1 from each side. I'll just circle that step and cancel here. X would be 4. So 3 to the 4 plus 1 power, that's fifth power, would equal 3 to the fifth power. Or look at this problem. You notice how we have the same base. 6 to the first power would equal 6 to the 2x minus 3 power. Well, since the bases are the same, they're both 6, then my powers would have to equal out. The first power has to equal the 2x minus 3 power. So you can add 3 to each side, divide each side by 2, which I guess they wrote that here, x would be 2. And then in the next example, you notice, again, we have the same base. We have a base 10, and these are equal, which means the 3x power has to equal the 2x plus 3 power. I can take away 2x, and I get 1x equals 3, so x is 3. What I'd like you to do is pause the video real quick, try these 3 questions where I need you to solve, and these bases are the same. And for your answers, for 1, you should have got x is 3, 2x is 1, and for number 3, you should have got x is negative 2. And again, in each of these questions, you can see I'm highlighting the bases were the same. So if the bases are the same and we have an equal statement, that means the powers are equal. Let's talk about how we handle solving exponential equations with unlike bases. Now, if you're going to solve an exponential equation with an unlike base, you're first going to have to rewrite each side of the equation so they have the same base. Okay? So this takes us back to an earlier lesson where we were working with roots and powers, lesson 2, where we work with radicals a little bit. Okay, so let's look at this problem. I have 5 to the x power equals 125. Now, these bases aren't the same. But 125 is the same as 5 to the third power. So I could write this as 5 to the x power equals 5 to the third power, because 5 to the third power is 125. Now, I want you to notice, now I do have the same base. So x would have to equal 3 now. X equals 3, which you see, okay? Or look at the next problem. I have 4 to the x power equals 2 to the x minus 3 power. Now, you notice the bases are not the same. But think about the number 4. Isn't 4 the same as 2 to the second power? Well, I can rewrite this then. I have 2 to the second power, that's 4, raised to the x power, would equal 2 to the x minus 3 power. Well, now, I do have the same base. So 2x would equal x minus 3, and then I can add 3 to, I misspoke, don't add 3 to each side, take away x from each side, and 1x would equal negative 3, which means x equals negative 3, just like you see here. Or look at this question. I have 9 to the x plus 2 power equals 27 raised to the x power. Now, these bases are not the same, but think about 27. 27 is 3 to the third power. So let me rewrite that. I have 3 to the third power raised to the x power. Isn't 9 the same as 3 to the second power? Think about that. Well, if I write 9 as 3 to the second power, and then I have that, got to write it this way, I guess, x plus 2 power, well, now I have the same base. I just got to clean this up a little bit, okay? So remember, when it's power to power, you multiply the bases. So I'm going to have to distribute, I misspoke, power to power, you multiply the exponents. So I have 3 to the 2x plus 4 power would equal 3 to the 3x power. Now the bases are the same, so 2x plus 4 would equal 3x. I can take away 2x from each side, and x equals 4. Okay? This technique also works if you have problems that have fractional bases. It's just that we'll have to use negative exponents. Like, look at this one. We have 1/2 to the x power equals 4. Okay, now I know 4 is 2 to the second power. And think about a half. I can move 2 to the numerator if I take the, remember, negative first power? So 2 to the negative first power is a half, so I'm just rewriting this. Well, now I have the same base of 2, so 2 to the negative 1x power would equal 2 to the second power. So now that my bases are the same, negative 1x equals 2, that means x equals negative 2. So all I'm doing here is manipulating to create a new base based on the prior properties of exponents that we learned back earlier in the chapter in 6.1 and 6.2. So a lot of this work is reapplying these principles. So again, here we are again. You've heard me say this time after time this year. You have to know the previous lesson to get to the next one, because we're going to use the techniques in that next lesson. You can never treat algebra like, well, I just need to get through it today and I don't have to worry about it tomorrow. No, these things keep popping back up. Let's look at one more. Let me just erase real quick. So for this one down here, 4 to the x plus 1 power equals 1 over 64. Now, I know that 64 is 4 cubed. So if I write 4 to the negative third power, that would equal 4 to the x plus 1 power. Well, now I have the same base. So x plus 1 would equal negative 3. I can take away 1, and x is negative 4. Okay? So I will definitely ask you to be able to solve these showing work. So I better write that down here. That's one of the I can, that you must be able to solve these showing your work. However, I also have some good news, okay? On the quizzes, I would make you show work, but remember, My chapter tests are multiple choice. There is another way you can solve these. It's by using your calculator, and you rarely hear me say this. When you use the calculator method, you don't have to show any work. Let me show you how the calculator method works. So take out your calculator. I'm going to go back to this sample problem, 3 to the x plus 1 power equals 3 to the 5th power. We're going to solve this on our calculator. So I'm going to show you how to do that right now. Here's the first thing we're going to do. We're going to write two equations, y equals 3 to the x plus 1 power and y equals 3 to the 5th power. We're then going to take both of these equations and type them in our calculator. So let's do that together. So in your calculator, hit the y equals key and type in the first equation. Now when you type it in, be careful. It's 3 to the x plus 1 power. So we're going to hit 3, caret key, parentheses, x plus 1 close parentheses. Now my second equation was y equals 3 to the 5th power. So y equals 3, caret key 5. Now, I'm going to hit graph, and they graph, but you don't, we're trying to find out where do these two curves meet. Now, you don't see it in the picture. I could zoom out if I wanted to, even though I don't have to, but I'm going to do it real quick just so I can see if we can see where they might meet. Kind of hard to tell on here. I'm not getting a good picture. So you might not always see the picture, but that's not the important things. Here's what is important. Do you see where it says calc, where I'm pointing? Hit second, calc. I want to know where these two curves intersect. That's option 5. If you press the enter key now 3 times, the first time it says first curve, press enter, hit it again for second curve, enter, and then hit it a third time, enter, and look at what they do. They write the answer to the problem. Remember, in our sample work, we got the answer was x equals 4. There's the answer, x equals 4. You can do these on your calculator. So this is great when it's a multiple choice test. You could even do these without showing any work. You just put the equation in your calculator, hit second, calc, intersect, enter 3 times, and that will tell you the answer for x every time. So before we continue with more graphing questions, because you can see that's the next thing, I kind of got ahead of myself. I talked about graphing with the calculator. Why don't you try 4 and 5 by showing work, not just typing them in your calculator. Try to change the bases to being equal and solving that way. Pause the video and do that. And I'm back. So on the first question, I can keep 4x the same, but if 256 is the same as 4 to the 4th power, if I take 4 times 4 times 4 times 4, I get 256. Now I do have the same base. So x equals 4. Or over here, I don't have the same base. It's 9 and 3. 9 is 3 squared. So I have base 3 and base 3. Now 2 times 2x is 4x. So since the bases are the same, 4x would equal x minus 6. And then I can take away 1x from each side and divide by 3. X is negative 2. So we've already talked about solving equations by graphing. That's super easy, okay? Sometimes it's impossible to rewrite each side of an exponential equation using the same base. So when that happens, you can just put it in your calculator, write 2 equations, and see where they meet. So this is what my example I showed you a minute ago didn't show you. On your calculator, for example, for this sample problem, they made y equal 1/2 to the x minus 1 power and y equals 7. So you notice when you graph this on your calculator, you would see a point of intersection. But then all you have to do after that is hit the second calc, enter, 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 and it ought to give you this answer. So let's do that real quick just to make sure you are getting that. We're going to type this in our calculator. Please type this in. Make sure you have what I have here. We have y equals 1/2 to the x minus 1 power and y equals 7. Then make sure you hit graph to get, and I'm getting the same picture we have in the book. And now the calc key, second, calc, option 5, and enter, enter, enter. And the answer is negative 1.81 for x. That's what the book said. Right here. Negative 1.81 for x and 7 for y. That's exactly what we had. So very easy to solve these using your calculator. So again, when you have a multiple choice test and there's no work required, you could type all these in on your calculator. So this would be a lesson, even if you think you're not great with mental math, this is something that you should be able to do well on just if you've paid attention here and know how to key these in. I'm going to pause the video here. If you have questions, make sure you ask in class.